So today we are going to continue our work with factoring quadratics. As you know, there is a lot of steps and we just want to continue to practice. So we're going to go ahead and take a look at a few more examples and solve them. So our title today is Even More Factoring Quadratics. Now today, just so we can get through a couple more examples, we are going to go all the way to find the roots, but we are going to not find the vertex. But we know when we're at the roots, once we found those, we'd add them together, divide by 2 to find the x, plug that back in to find the y. And we'll do more practice with that later. So our first example that we're going to go over is 7x squared minus 31x minus 20. Okay, and those are pretty big numbers. So I start and see, hey, 7's my smallest. Can I have that go evenly into 31 or 20? I need both, and it doesn't. So I know that I need to just start jumping in and doing the work, probably using a calculator as my numbers get bigger. So A is 7, which is my coefficient in front of my x squared. My B is negative 31, my coefficient in front of my x, and my C is negative 20. So I'm going to go ahead and put that into my diamond problem. I'm going to multiply A times C, which is negative 140 for my top portion, and B bottom is that negative 31. Now I'm going to go ahead and figure out exactly what my side answers are going to be. So 1 times 140 gives me 141 or 139. 2 times 70 gives me 68 or 72. 3, I'm going to see if that goes in evenly. So 140 divided by 3, it does not. 140 divided by 4 does. So we have 4 times 35, which adds to 39, subtracts to 31, and that's what I'm looking for. So I have a 4 and a 35. It needs to be a negative 31, so that's going to be minus 35. Now I'm going to go ahead and fill out my generic rectangle. I go back to the original problem for my 7x squared in the bottom left, my original problem for the negative 20 in the upper right, and then I'm going to take these and add x for my 2 remaining squares. So I have 4x and negative 35x. Now I'm going to go ahead and pull out those answers for my problem in product form. So we have a 7 and a negative 35. 7 does go evenly, so I'm going to take 7 out, and I see there's 2 x's here and x here. At this point, I can go ahead and find out my multiplication. So I know 7x times x is 7x squared. 7x times negative 5 is negative 35x, and x times 4 is 4x. So my product form is going to be x minus 5 times 7x plus 4. Now I'm going to go ahead and find my zeros, set them equal to 0, and solve. So x minus 5, add 5 to both sides, is going to give me 1 root of 5. And then for this one, I'm going to write down just because it's a little trickier. So that's 7x equals negative 4. Divide both sides by 7. And my second root, my 0, is negative 4 sevenths. Now, once again, I could write them like x equals or as ordered pairs. That would be the ordered pair 5, 0, and that would be the ordered pair negative 4 sevenths, 0. So just make sure you're paying attention to how it's being asked of you. Okay, so once again, if I wanted to go ahead and find my vertex, I would now add those together, divide by 2 to find the x, plug it back into the equation to solve for y. Okay, let's go ahead and look at a second example. Example number 2 is 2x squared minus 5x minus 4. Okay, so we're going to go ahead and take out our a, which is 2, our b, which is negative 5, and our c, which is negative 4. I'm going to go ahead and multiply a times c, which is negative 8 for up top, and b bottom, negative 5. So I have 1 times 8, which adds to 9, subtracts to 7. I'm looking for a 5. I have 2 times 4, which adds to 6, subtracts to 2. And then that's it. There aren't any more. So what does that mean? That means that this equation, because we can't get a right and left, the answer is not factorable. Now, we're going to add this word right underneath it. Now, we're going to end up being able to solve this using the quadratic formula next class. So I'm going to show you why it's not factorable. If we go ahead and go into our Desmos, and we type in this equation, 2x squared minus 5x minus 4. Notice here we do have roots. And so we know it's factorable because we have roots. But we can't use this method to do so. And that's why we're going to learn in a couple more sections the quadratic formula, where you're just going to plug in your A and B and C into your formula and solve that way. Now, there are some equations that are not factorable for a different reason. And that is because they don't have any roots. So if we have this, and we're crazy settings here, let's go ahead and move back so that we have 5, negative 5. Oops, strike that, reverse. What we see here, it's like, I don't want you to do that, Mrs. Burst. Okay, let's go. Negative 5, 5. There's a lot of numbers in there. Okay, there we go. So as you can see, this one would be not factorable because of the fact that it doesn't cross either of the x-axes. So it doesn't have any roots. So that could be one reason why it's not factorable. We also have one of the equations we did last class, x squared minus 25, where it's completely equal right here. And that's when we have a 0 for our vertex. However, we could have an equation that looked like this. It's going to be a perfect square here, so that could be x squared minus, let's do 4x squared. So it's going to be a perfect square here minus 20x plus 25. And this is our third possible situation for a graph. Notice it only has one x-intercept, and that intercept is the vertex. So there's 3 circumstances you can see. We can have one x-intercept, we can have 2, which are most of the ones we've been solving, or we can have 1. And there's special terms and special names for each of these. This one right here is a perfect square trinomial. And then we have a difference of squares, which is the one that we talked about last class, like this, right? And then we have our normal ones as well. So those are kind of special circumstances, special situations. Okay, so not factorable now, but as you could tell from that problem, there was roots there. And so we will be able to, once we go a couple more sections in, I'll teach you how to solve that. Now, we came across this kind of weird situation. Like I said, this is our difference of squares. And this is where you have one of your letters missing. But that doesn't matter. We can simply solve. A is 1, B is 0, and C is negative 36. We go ahead and have that negative 36 times 1 up top, and our B goes on the bottom. And this is where we end up with opposites of each other, 6 and a negative 6. And so we go ahead and plug those answers into our generic rectangle. We have an x squared, we have a negative 36, and then we change that into a 6x and a negative 6x. Okay? Then we go ahead and solve. We like when we start with that x squared because we can immediately go x and x. We then have a minus 6, and here we have a positive 6. So our answer is x minus 6 times x plus 6. And then when we find our roots for that, set them equal to 0, we have a root of 6 and a root of negative 6. And we know our y-intercept is our vertex. So our vertex is going to be 0, negative 36. So that is a special circumstance. Let's go ahead and take a look at 2x squared minus 8x plus 6. So this is the type of problem where you want to go ahead and reduce it first and go ahead and factor. We can see they're all even, so we can go ahead and take that 2 out. That leaves us x squared. Negative 8 divided by 2 is negative 4x, and 6 divided by 2 is positive 3. And then we go ahead and we solve with this portion of the problem. So our a is 1, our b is negative 4, and our c is 3. You just can't forget to leave that out of our product form. So we want to not forget that too. So a times c, 1 times 3 is 3. B bottom, B bottom, B bottom. And the only way to get a 3 is a 3 times 1. And they both have to be negative to add to negative 4. So we transfer that over to our generic rectangle. Our 2x squared goes in the bottom left. Our 6 goes in the upper right. Oop, I just messed that up, ladies and gentlemen, because we're using this one right here. So that's x squared and 3. So remember to take out from your factored form. Then we have our negative 3x here and our negative x here. And then we're going to find the outsides. We have an x and an x. That makes this a negative 1. And it makes this one a negative 3. So in our product form, and this is where we said to be careful, we want to make sure that that 2 is on the outside, and then x minus 1 times x minus 3. We're going to set each of those equal to 0, and we're going to have one root at 1 and their other root at positive 3. And then we can add those together, divide by 2. 4 divided by 2 is 2. And then plug that back in. 2 minus 1 is 1. 2 minus 3 is negative 1. And that's going to be our vertex. Okay, once again, the extra little special step, we will be focusing on that in a little bit as well. Okay, our very last one that we're going to work on is 30x squared minus 45x. And like I said, always look to see if you can factor first because it makes the problem a lot easier. So if I could see that we could pull out 15x here, then I know that that's going to be 2x, and then over here, minus 3. Now, notice something happened here. I don't actually even have to use a generic rectangle or a diamond problem. I can just set each of these equal to 0. 15x equals 0, x equals 0. So one of my roots is going to be at 0. My other one, 2x minus 3 is equal to 0. 2x is equal to 3. X is equal to 3 halves. So if I could see that I pulled it out, I saved myself a lot of work. Now, I could have still done this using the other technique if I didn't see that. My A would be 30, my B would be negative 45, and my C would be 0 in this case. So I would go ahead, and I would have the 0 up top, and I would go ahead and have a negative 45 below. Now, the only way to multiply to get a 0 is one of the sides has to be 0. And then to add, it's going to be a 0 and a 45. So that's kind of another little trick. If you see that 0 up top, then you know to add one of them is going to be 0, and the other one's going to be the down below number itself. We could then go ahead and take in our 30x squared over here. We have a 0 up here, and then we have a 0x here, which is just 0, and we have a negative 45x here. So as we're doing this, we're then going to pull out our 15x here. 15x times 2x. And this, of course, is just going to be a 0. And then down here, 15 times negative 3. And that's how we get our side of 15x plus 0, which is just 15x, times 2x minus 3. So if you could have spotted that right away, then that is going to save you all of this work and a little bit of confusion with all those zeros as well. Once again, we're going to continue working on this with our Desmos activities.